Hello everybody and welcome to this video once again. Now in this video we are going to discuss about LiDAR. LiDAR basically stands for light imaging detection and ranging. Now LiDAR sensors, they emit invisible laser lights to scan and detect objects in near or far vicinity of the sensors and create a 3D map of the objects and surroundings on the display screen. Understand this very carefully. It creates a 3D map of the objects. And how does it create? In automotive applications of LiDAR technology, most of the LiDAR sensors are installed on top of the vehicle. So there is a LiDAR sensor which is on the top of the vehicle, and LiDAR sensors continuously rotate and generate thousands of laser pulses per second. It continuously rotates at 360 degrees at very high RPM and generates thousands of laser pulses per second. So imagine an ordinary camera which is rotating at a very high velocity, a very high RPM, and taking thousands and thousands of photographs per second. And these thousands and thousands of photographs per second are combined to form a 3D map. These high-speed laser beams from LiDAR are continuously emitted in 360-degree surroundings of the vehicle and are reflected by the objects in the way. With the use of complex machine learning algorithms, the data received through this activity is converted into real-time 3D graphics, which are often displayed as 3D images or 3D maps of surrounding objects. Now, I reiterate one thing. Imagine a camera which is rotating at a very high RPM and taking thousands and thousands of photographs of the surrounding in totally 360 degrees field of view, and by combining or adding or stitching together, so to speak, stitching together these thousands of photographs, it prepares a 3D map. Okay, an advanced driver assistance system based on the LiDAR sensors are most innovative and efficient technologies for autonomous vehicles. So of all the sensors which we have discussed so far, radar or ultrasonic sensor or camera, this is considered to be very state of art, and this is considered to be the most modern technology. Along with the vision and radar based systems, LiDAR systems provide high accuracy, precision in object detection and recognition in ADAS. Now just take a look at these photographs, look at all the various types of LiDARs that are available. Basically there are two types of LiDARs, electromechanical LiDAR and solid state LiDAR. Now I'm not going to deep into that because that is slightly beyond the scope of this particular presentation, and moreover it is just it just adds to the academic knowledge. It does not add much to the it does not add much value to the working of the LiDAR. Okay, and I want all of you to see this particular drawing, this this particular drawing which is mentioned here. This is called point cloud, and LiDAR, as it is taking number of photographs by rotating at a very high RPM, this is how the ECU perceives the LiDAR. Okay, this is how the ECU perceives the LiDAR, and this is how ECU detects that this is a car. So let me take a different pointer. Yeah, ECU perceives this is a car, these are pedestrians, these are trees, this is a T intersection, again this is a car, now this is a pedestrian who is trying to cross the road. So depending on this point cloud, LiDAR clearly understands what exactly is the nature of the target, whether it is a pedestrian or a motorbike or a cycle or an animal which is trying to cross the road. All these things are understood by this point cloud. All right, now I want all of you to take a look at all these various types of various types of this lidars. Okay, now this velodyne is a very strong player in lidar, and this velodyne is a very big promoter of this lidar. Frankly speaking, many OEMs are not exactly encouraging this lidar because of the cost, but velodyne is a big promoter of this lidar, and it is one of the main suppliers of Google Waymo. Now, in this particular slide, I have consolidated the various advantages and disadvantages of the various sensors. As you can see here, where I have put the plus. that means that it is adding a huge advantage. For example, radar is advantages in various weather conditions, lightning conditions, and camera is advantages when it comes to data density or classification or pedestrian detection. Ultrasonic is advantages in commercial viability, different weather conditions, but it is very poor when it comes to distance range. It is very poor when it comes to classification. It comes to pedestrian detection. So understand this. Based on this particular slide, you can understand what are the advantages and disadvantages, where exactly some sensors are faring well and where exactly some sensors are faring very poorly. Now, because of this fusion, where you are fusing the data from the various sensors, finally everything becomes all right. For all the lighting conditions, a fused data is working well. For distance also it is working well. For classification it's working well. Pedestrian detection is working well. Now, what exactly is fusion? I'll be discussing in the coming videos. So, but for now, just understand the fusion is nothing but taking the data from different sensors and combining them or adding them, so to speak, because these words combining and adding, they convey a slightly vague meaning, but still for your understanding, you understand that adding and combining the data from different kinds of data from different kinds of sensors, it is what makes the final output a viable solution in various weather conditions and in various aspects, whether it's a distance accuracy or velocity or data density. Fused data works effectively. Okay, that's what I want all of you to understand.